Hey guys. Alright, so today we're going to work on recursive sequence. So, recursive sequence, it's a follow-up to arithmetic sequence that you guys have learned already. We're going to talk more about that as we get into the lesson. So, for the do now, it says the graphs of y equals x squared minus 3 and y equals 3x minus 4 intersect at approximately. So, there are two ways we can solve this. We can solve this algebraically, but as you can see, with all of these numbers here, we're not going to get nice numbers. It's approximate, which means that it's going to be irrational. We have a calculator. We're going to use the calculator. So in order to do that, we're going to go to y equals, and we're going to type in both of these equations together. So we have x squared minus 3. We're going to put that in for y1. And for y2, we're going to type in the second equation, 3x minus 4. When we press graph, we see two equations here. Now we can see 2 points where they intersect, and we could sort of tell what the answer will be, but we want to be absolutely sure what the answer is. In order to do that, we're going to calculate. You see this little blue part here that says calc? We're going to use that in order to calculate the intersection. I'm going to press second, trace, and we're going to go to intersect. That's what we want to find. So we're going to press 5. Now we want to get as close as we can to that point of intersection. It doesn't have to be 100% exact, but close enough would work. We press enter 3 times. 1, 2, 3. So the first intersection that they're telling us is 0.38 and negative 2.85. So 0.38, negative 2.85. Now it says that only. Here's the thing. If we look at this graph, I see that there are 2 points here. It's not just going to be that 1 point. So that's out. Oops. So yeah, that one's out. Same thing for this problem right here. It's saying that it's only 1 point. That one's also out. There are 2 points to this. Now, they kind of gave us an answer by giving us these 2 points here. However, let's just try and find the next point that we need. So it's definitely between 3 and 4. We see that there is 0.38 here and negative 2.85 for both of them. So let's find the second point. We're going to do the same thing. Press second trace, go to 5, and now we're going to scroll up to this next point, somewhere around there. Press enter 3 times. 1, 2, 3. And we have 2.6 and 3.85. So 2.6 and then 3.85. Notice they have that here as well, but they switched it. Remember, x comes first, y comes last. So our answer for this problem is 3, 4 is out. Now, I did say that they kind of gave us the answer by giving us these two answer choices, but don't always rely on that. All right, by chance it just worked there. Okay, moving on to recursive sequence. So recursive sequence is a sequence in which you must find all the terms starting with A1, A sub 1. You have to find every single term before the one that you actually want to find. Recursive sequence will always give us the first term. Very important. And we'll have to find every term after that. So for example, if we need to find A sub 5, so they're asking us to find the 5th term here. We have to find A1, which is given to us, A2, A3, and A4 in order to find A5. Now, a couple of important labels here. A sub n minus 1 or f n minus 1. Both of these means that we're talking about the term before. Okay? So if an is the term that we want, then a n minus 1, this is just talking about the previous term. The term before the one that we want. So I'm going to write previous term. Very, very, very important. Recursive sequence, you will always see that. Now, when you hear the word recursive, you should think about reoccurring, something that happens over and over and over and over again. You're going to see with recursive sequences, we're going to get a rule, and we're going to follow that rule over and over and over until we get the term that we want. So here's the first problem. It says find the first 4 terms of the sequence in which a sub 1 is 8, and a sub n is equal to a sub n minus 1 plus 3. Let's break this down. We need to find the first 4 terms. So they're telling me I need to find a1, a2, a3, and a4. Now there's a long way to do it, but it's the correct way, and there's a shorter way to do it that's a little bit of a shortcut. I'm going to show you both, but for now, for the first one, I'm going to show you the long way. It's good to know it. A sub 1, we know that that's 8. We don't need to solve anything for it, okay? Remember, this here, this annotation here, this is going to be known as our previous term. Oops, can't spell previous. Good thing this is a math class. Previous term. Okay, so let's dissect exactly what they're saying. They're saying that, hey, your first term is 8. However, if you want to find another term, take the previous term and add 3. So in order to find our next term, a sub 2, they said take our previous term. I'm going to highlight our previous term in green. So that's what our previous term is. They say take our previous term, which was 8, and follow your rule. Your rule is to add 3 to it, so plus 3. Okay. 8 plus 3 is 11. Boom. There's our second term. Okay. To find a sub 3, we're going to follow the same rule again. They're telling us, hey, take your previous term and add 3 to it. So our previous term was 11. If we're trying to find our third term, we look back to our second term. Our previous term was 11. All right, we're going to take that and plug that in right over here. Take our previous term and add 3. Okay. Plus 3. So our previous term was 11. We add 3 to it. We get 14. And we got to do this one more time. So again, I take my previous term. So to find a sub 4, I need to take my previous term, which was 14. I'm going to draw an arrow. That's going to go right here. So 14. And then add 3. Plus 3. 14 plus 3 is 17. Okay? So we found our first 4 terms. I like to write them out a little bit neater so whoever's grading it, they know exactly what my answer is. So on the side here, I'm going to write a sub 1 is 8. A sub 2 is 11. A sub 3 is 14. And a sub 4 is 17. And that's it. I found my first 4 terms. Now, I did say that there was a little bit of an easier way. I like to do this a bit graphically so I can see it better. In order to do that, I'm going to write out the terms that I need. So the 4 terms, I'm going to write A1, A2, A3, and A4. So these are the 4 terms that I need. They told me what my first term was. It was 8. I'm going to write that in here. Okay. Now, I need to figure out the rule. There's a common rule, a common pattern that I need to figure out in order to find the next terms. Now, to go from 8 to 11, from 11 to 14, from 14 to 17, you guys can clearly see the rule is 3. But did they give that rule to us? Yeah, they did. They told us that, I'm going to write down the problem here again. an is equal to an minus 1 plus 3. The rule for us is that we need to take the previous term and add 3 every single time. So for this way that I'm doing it, here's how you show it. Just draw an arrow from one term to the next, and you're going to write your rule here. There can be multiple rules. In this case, there's just one, but sometimes you might need to multiply and then add, or divide and then subtract. There can be a combination of things. So you're going to write your rule with the arrow every single time. So my rule was plus 3. Rule here, plus 3. And that's it. I'm just going to take my previous term and follow my rule. 8 plus 3 is 11. 11 plus 3 is 14. 14 plus 3 is 17. Done. Whichever way you guys like to complete these problems, it's up to you. Both of them will always work for these types of problems, but I personally like this bottom one a little bit more, only because it's graphical and I can see it better. Okay? So let's move on. So they say write the recursive formula for the sequence. Now, notice they gave us the sequence, and now we need to find the rule. We need to figure out what's going on. So essentially, we need a couple of things. We need A1, that's always going to be first for our recursive formula, and we need an equals an minus 1. And then either plus something or minus something. So we need something like this here. Let's start it. So the first part is always easy. A1 is our first term, and they gave it to us, 2. The second part, let's figure it out. An equals, what's the pattern? What's going on here in order to get to the next term? So let's try adding first. So 2 plus what gives me 11? In order to solve that, all we have to do is just do 11 minus 2. 11 minus 2 gives us 9. Okay, so I see that right now there's a plus 9. It's not a pattern yet because we only looked at 2 terms. But let's see if this continues. What's 20 minus 11? 20 minus 11 is also 9. Okay, so it seems like our rule so far is that we're just adding 9. But we have to make sure with the last one that that rule still stays the same. Now you can look at this and say, oh, all right, 29 minus 20 is equal to 9. So I'm going to write that rule down here. To go from this term to that term, I need to add 9. Okay, so what this is telling me is that my first term is 2. To get every other term after that, I take my previous term. So I'm going to put that in green. I take my previous term. And my rule for this one is that I'm adding 9. So plus 9. And that's it. That's all that you need to do for this problem here. You can check your work again just by making sure. You start with 2, and to find the next term, you add 9, which is 11, that works. 11 plus 9 is 20, that works. 20 plus 9 is 29, that works. So we found this rule based off of the sequence that is given here. Okay? Remember, you do need a sub 1, and you need an equals an minus 1, either plus something, or minus something, or multiplied by something. That's up to you to figure out. Alright, let's move on. So now, they can also ask a question where, let me get rid of that box. Yeah. They can also ask a question where if you have the first term is 7, what's the third term? Now this is very interesting, the kind of notation that they're using here. It looks like it says f of 1. And yeah, this is also another way that they can show arithmetic or recursive sequences. So they're telling you that this f of 1, think of f of 1 as a sub 1. They're both the same exact thing. They both mean first term. So that means if we have f parentheses n minus 1, that's the same thing as a sub n minus 1. They both mean the same thing. These both mean previous term. So don't get confused by it. It's just a different notation. Okay. So for this one, we're going to do the long way first, and then we're going to try the trick that I showed you guys afterwards. So first term, they're saying that f of 1 equals 7. Now they're asking for f of 3, so we need to find f of 2. We can't just jump to f of 3. Now, be careful. You can't just plug in 3 into n. That's not how this works, okay? So instead, I'm going to write 3 here. Oops, not 3. I need to find f of 2 first, and then find f of 3. Okay. So in order to find f of 2, our rule says that we need to, so I'm going to rewrite everything else. I have 6, and instead of writing fn minus 1, I'm going to write the term before. We know that this means previous term. So the previous term that we got was 7. So 7 is going to go inside here. And then I'm going to rewrite the rest of the equation. So 6, 7 goes inside of this whole thing, and then minus 1. Okay? 6 times 7 is 42, minus 1 is 41. So that's our second term. Now let's do the same thing for our third term. So again, I follow my rule. I have 6. Inside the parentheses here is our previous term. Our previous term was 41. Remember, fn minus 1 just means previous term. So I'm going to write 41 inside here. 41 minus 1 equals. Now my math isn't all that good, but I believe this is 246 minus 1, 245. Let's just double check it. 6 parentheses 41 minus 1. Yay, it's 245. So for this answer here, I'm mixing up my colors here. So minus 1. This one's equal to 245. Now, for our answer, we're not going to rewrite it like this one here. We don't need to write all of our answers. They're only asking for a specific one. The only specific one that they're asking for is f of 3. So we just write f of 3 equals 245. And that's my final answer. Okay. I did say there was we could use that shortcut here. Let's see how we would use that shortcut. Okay. So I start off with my 3 terms. We have f of 1, f of 2, and f of 3. Now they told us f of 1 is 7. They already gave us our first term. We need to figure out the rule that we are using in order to get to our next term. So I draw my arrows because I know that there's some rule that we're going to follow every single time. Now for this one, there are 2 rules, like I said before. For the first rule, and you know what, I'm going to just isolate this a little bit so you can see what the rule is. So this here is our previous term. Just slide it over a little bit. All right. So this is our rule. It's saying to get our next term, take our previous term and do a couple of things. We're going to multiply by 6 first and then subtract 1. Those are our 2 rules for this problem. So my 2 rules, we're going to multiply. So multiply by 6. And then we're going to subtract 1. So we're just going to follow that same rule all throughout. So multiply by 6, and then subtract 1. Alright, so if we follow this, 6 times 7, 6 times 7 is 42, minus 1 is 41. So I'll write that in here. 41. And now I'm going to take that number, 41, I'm going to multiply it by 6 times 6, and then subtract 1. Minus 1. And that gives us 245. And there is our final answer. Okay? If we do it the long way like this, that's totally fine. There's actually a longer way where you have to plug in even more stuff, and it gets way too confusing. This is a short way. This is even shorter. It's up to you guys, whichever you want to use. Okay. Now, here's where you would see a region-style problem. It says, given the function f of n defined by the following. Now, this is very important. this sort of notation here, it's very important. Whenever you see something like this, you gotta think recursive. Now, my handwriting isn't the best right now, so I'm gonna type that out. This is telling us that this is a recursive function. Okay. Very important. Now that we know that this is a recursive function, it says which set could represent the range of the function. All they're trying to ask here really is, if I follow this rule, what numbers will I get? Okay. First thing, they're saying f of 1 is equal to 2. But remember, f of 1 is my first term. Right away, we can eliminate 2 answers. So let's look at our set. Our first term must be 2. There's a 2 here, that's good. There's a 2 here, that's good. There's a negative 8 here. That's bad. And there's a negative 10 here. That's bad. Okay? Okay. So, we need to figure out what's the other terms. Now, notice the second term. There's a 4 and there's a negative 8. Once we find the second term, we're good. We know that which one's our answer here. Let's take a look. It says that the first term is 2. This is f of 1. I'm going to use a shortcut here. So for f of 2, let's figure out our rule. Let's figure out what that rule will be. So in order to move over, remember, when we're doing the rule, we're always using order of operations. So multiplication and division comes before addition and subtraction. So our rule, it says that, hey, take the previous term, multiply it by negative 5, see that there's a multiplication here, and then add 2. So the first thing we're going to do is multiply by negative 5, and then we're going to add 2. So I take my answer, my previous term, 2. I multiply by negative 5, and then I add 2, plus 2. And that gives me negative 8. Boom, I got my answer. Right there, negative 8. It's not 4, so it's negative 8. Now, just to be sure, always try and find one more term, just to be on the safe side. Make sure that this is working. Because if you got something like, let's say, 39 here, then maybe you did something wrong, and you're going to want to check yourself. So again, draw my arrow. My rule is multiply by negative 5, add 2. And let's try it. So I have negative 8. And I'm going to multiply by negative 5. So times negative 5 gives me 40, plus 2, and it gives me 42. So we found out that that next term is indeed 42. So I have 3 is 42. So our third term must be 42. I know that that answer is right. I'm good. All right, moving on. And it says for this one, which recursively defined function. They are telling us it's recursive. Which recursively defined function represents the sequence 3, 7, 15, 31. Okay. Now, a couple of things. First thing is that it's saying that our first term is 3. So right now we can't cross anything out because that's true. Our first term is 3. Now, look at this extra part over here. They changed something around. And I'm curious how many of you guys noticed that something is changed around. Instead of having f of n equals, let's say, f of n minus 1, and then plus something at the end. Let's say plus, I don't know, star. Instead, they changed it up on you. They're saying, hey, our next term, f of n plus 1, it means take the term and then do something with it. they both mean the same thing. If I have, let's say if I have n here, and then I have n minus 1, that's the same thing as saying, okay, I have n plus 1 here, just take n. It can get a little bit confusing. I get that. But that's what the Regis is trying to do. They're trying to confuse you to see if you can work through that confusion and realize that these both mean the same thing. So don't get confused with that. Take a look at this. Each one here says n plus 1, n plus 1, n plus 1. Remember, it's still a recursive function. They told you it's still a recursive function. Next thing, that's very interesting, is that you see how the f of n is an exponent here? We didn't really learn about having that as an exponent. So for these two, I'd be highly suspicious if those are the answers. So I'm going to focus on 3 and 4 for now, see if we find our answer, but then look at 1 and 2 and see what exactly they're talking about. Okay, so we're going to work on this as normal. So for the first one here, it says f of n plus 1, all that stuff. I'm going to actually rewrite this just so I'm more familiar with it. I can rewrite this as f of n equals 2 f of n minus 1 plus 1. As you can see, they're exactly the same. Now, what they're trying to say to do here is we need to figure out our rule regardless. Let's figure out our rule and make sure that it's making sense. So I just need about 3 terms to see if this works. So f of 1, f of 2, f of 3. Okay. F of 1, they already told us that it's 3, so we're good. F of 2, we know it should be 7. Let's see if that works. Now our rule that they gave to us is we're going to multiply by 2, so times 2, and then add 1. Multiply by 2, add 1. So 3 times 2 is 6, plus 1, which is 7. Okay, so that checks out so far. We get 7. That seems like it's right. Let's just find the next term. It's always important to find the next term just to make sure that it works. So our rule for this one is multiply by 2, add 1. Same thing as before. 7 times 2 plus 1. And we get 15. And that's what we wanted. The next one should be 15. Okay. So as of right now, this seems like it works. It seems like 3 is our answer. But let's just check the next one. Let's check 4. Okay? So instead of rewriting this one, we can now just look at this and we know what our rule is. So for this one, I'm going to write it over here. So this was answer choice 3. I'll write that in blue. So answer choice 4 is going to be down here. So we have f of 1, f of 2, and f of 3. Okay, so we start off with our first term, which is 3, and we find our rule. So our rule for number 4 says we're going to multiply by 3 and then subtract 2. So times 3 minus 2. Okay, so 3 times 3 is 9 minus 2, which is 7. Huh. Would you look at that? That also works. This is why you need to find more than just 2 terms. Let's see if this pattern still works afterwards. Okay. So again, we're multiplying by 3. Subtract 2. So I have 7 times 3, and then minus 2. Alright, so that gives us 8. Wait, I did that wrong. That doesn't make sense. Let's try it again. 7 times 3. I think I put plus 3 before. Yep. 7 times 3 gives us 21, and then minus 2 gives us 19. Okay, so this is 19. We wanted it to be 15, as you can see here. So thankfully, this one's wrong. So we didn't do anything wrong so far. It seems like 3 is the answer. But like I said, I did want to talk about 1 and 2 really quickly. So in order to do 1 and 2, it's kind of weird. It's saying take our base of 2, raise it to the previous term, and then subtract 1 or add 3. Again, something like that you don't see for the regions, really. It's odd that they even put that as an answer choice. So our answer choice really is 3 for this problem. But if you want to see what this looks like, I'll show it to you really quickly. If not, skip ahead. So for answer choice 1, so we have our 3 terms here. Keep it the same color. So we have f of 1, f of 2, f of 3. So our first term is 3. Now our rule is very weird. It says do 2 to the previous term power, and then we add 3. So we're going to type in 2 raised to the third power, because that's our previous term, and then plus 3. And that gives us 11. Right away, that one's wrong. We know that's wrong. All right, and for the next one, if you were to do this, the first term would be right, like you'd get 7, but when you try it again, you're not going to get 15. It's going to be some crazy number. I'll just show you that one as well. Why not? Again, you can skip ahead if you don't want to see all this. So for 2, number 2, we have f of 1, f of 2, and f of 3. Hopefully you guys are seeing that this method is a lot easier and it takes up a lot less space. That's why I'm using it a lot more. So for number 2, it's saying that we need to take 2, raise it to the previous term, and then subtract 1. So pretty much the same thing as this rule, but instead of adding 3, we're subtracting 1. So our first term is 3. Our rule, to go from here to here, and here to here, we're going to take 2 and raise it to that previous term, and then subtract 1. 2 raised to the previous term, and subtract 1. Okay, so we have 2 raised to the third power. That was our previous term. And then subtract 1. That gives us 7. That works, clearly. But here's where it gets crazy. I take 2 and raise that to the previous power. So 2 raised to the 7th power. We get 128 right away. We know what's wrong. But let's just continue. Minus 1 is 127. They did not want 127. That's way too high. They were looking for 31. So I know that these two are also out. It's answer choice 3. Okay. So we did quite a bit. Quite a bit. You have these problems here. Definitely do the first 4. The challenge is optional. I'm going to tell you that the challenge is optional. But to be honest, the challenge is not that bad. It just says to write a recursive formula for the sequence, and it's helpful to get some practice with that. But definitely do numbers 1 through 4. Okay? As always, there will be Delta Math posted, so good luck with that as well. Hope you guys are staying safe, and until next time, bye-bye.